So, final talk of the evening. I'm going to hand over to Manuel, who's going to talk about, I was going to say the T word and the M word, but I don't know how they're said, despite having used both of them for a number of times. Just traffic, yeah. And mesh.
Actually, I just removed mesh because I saw in the proposal we sent you that mesh was not listed, and we will probably hit the 30 minutes. So it's just traffic tonight.
Just traffic. Okay. I think I'm happy with that. I'll hand it over to you, Manuel. Thank you.
Thanks. Hey guys, thanks. Thanks for the warm introduction. I really try to do not salesy. If I do, just throw your, I don't know, cell phone, stones, whatever you have, right at me, and I will shut the fuck up. Just 2 sentences about me. I'm Manuel, as already said. I'm currently working as the head of product open source for the company behind Traffic for Containers. I'm also a long-time maintainer on Traffic, so it's a bit more than 3 years by now. So finally heading over in the company and getting paid for what you do on your basis anyway was the logical next step to take. You can also find me on Twitter and GitHub. If you have feedback after the talk or whatever, please reach out and then tell me, because I like feedback. So the hopefully only sales part for today. We are Containers. We believe in open source. We are open core, so that's where we come from. We build Traffic, we build Traffic Enterprise, and we build Mesh. We also, of course, offer commercial support in case you have issues. We are currently 30 people distributed around the globe. We are currently in 9 different countries. So we are really taking colleagues where the colleagues are and not going for, oh no, you need to be in my office, because that's weird anyways. 90% of our people are tech. I guess the only persons that are not tech is probably our back office. That's literally it. So that's quite cool to work in. So with that being said, let's go to the real fun. And the reason why we actually talked to this, or to figure that, is have a quick look at the evolution of software. Because where we go in the 90s, what we usually encountered is what we call the spaghetti-oriented architecture, or better known as copy and paste. Because you just move your shit, you just copy and paste your shit all around, and somehow this monolithic thing is working. The next evolution is not necessarily better, just different. It's what we call the Lasagna-oriented architecture. I guess, especially, I forgot the name from the speaker before, but if she's in financial services or so with big, heavy Java-written monolith, she will know all the layers of Doom. Yeah, lots of spaghettis, lots of lasagna, layers of Doom everywhere. So that's probably not the best decision either. And then around the 2010, these little things called microservices emerged out of the need that they figured that they need to change something. And maybe it's the better. So that's where we are currently, and that's where we come from, because by definition, microservices sound really, really great. I mean, they're all just there. It's tiny pieces of code. They just work together flawlessly without any issues at all. However, the reality is usually more like that. So that's shit goes south no matter what, and it will go south. So yeah, you have to adjust and you have to change something to somehow limit where it goes south. What is the logical next step after going for microservices is that you actually don't have a clue anymore where your services is running. Is it running? Is it dead? Is it there? Is it gone? Whatever. So, and when you then start to look it up and to try to solve that particular issue, you usually stumble across one or multiple of these tools. So whatever you take to solve what you think you need to solve your need. These days, Kubernetes has somehow won the war in terms of adoption, but I don't necessarily agree that everyone that uses Kubernetes needs Kubernetes, but that would be enough story for a different session. So when adopting these tools and trying to combine that with traditional reverse proxies or traditional load balancers, what you can easily end is something like this, because you have super long configuration files to write. You have to keep them in sync because Because maybe your container just died and the internal IP changed, and then you have to redo all your things. And that's a little tedious and a little not the optimal solution, let's say. So what we thought is when we encountered that a couple years ago is rewriting this configuration file is really just shit. So why do we really still to do this? And sadly, luckily, there's a solution for that. That where we come into play as something that we call dynamic load balancer or reverse proxy or edge router or call it whatever buzzword you want to throw at it. What it necessarily does is it stays in between. Like you have the access from the internet going to your microservice or even your monolithic application or whatever. And on the other hand, you have your infrastructure, your orchestrator with all your stuff. And somehow these worlds need to talk again and need to work together. Just 5 key facts about the project itself. We have more than 27,000 stars in GitHub as of today. More than 450 different people touch the code or the documentation or whatever parts of it. So it's a massive community around. We just had, actually, I guess it's 1.5 today, but whatever. More than 1.4 billions of downloads out of the official Docker Hub image. So that's quite some traction. And we already have, or we know of more than 100K living instances. So that thing is somehow battle tested, and it seems to work. What we did at the end of last year is we re-evaluated us and we released a new major version based on the community feedback, because as seen, we have a massive community and they overshot us with feedback. And about technical depth, we figured, okay, we have technical depth. The features our community want, we just can't get them in there. It's like a no-go. So we needed to start from scratch to implement the features the community asked for. But with that being said, how does it actually work, and what is like the core concept? So what, as a user, are you facing? As said, traffic is an edge router, load balancer, reverse proxy, whatever. And it takes incoming requests and routes them to the infrastructure. So far, so good, so easy. The cool thing is it dynamically discovers the services. So whatever you have running in your infrastructure, and the parts running in your infrastructure are supported by traffic will figure it. He will figure that some domains should be mapped to this microservice, some domains should be mapped to this microservice, and you don't have to rewrite your 300 kilometers configuration file over and over again. How does it work? Traffic in itself is kind of split in 3 different core parts, let's say. What you have is the entry point as like the top level, which basically describes what am I listening to. So the most basic example is ports. Then the next level directly after entry point is what we call the router. The router basically defines what does the request need to look like which host, which path, which headers need to be present, stuff like that. And then in combination, routers or routers have a middleware. A middleware is everything that tampers with the request, like rewriting, redirecting, adding headers, removing headers, stripping paths, buffering, compress, I don't know, stuff like that. Everything that just tampers with the actual request or with the response. And then last but not least, there's the service, because someone needs to answer. So if we have an easy example, we could have, for example, 3 entry points, one for base HTTP, one for plain HTTPS, and potentially one for your Jenkins agent, or I don't know, which also does forward some headers, just because he can. And then from the entry point, it goes to the router. So there would be a router which would have a rule, which means host app.domain, meaning that router is effective for requests coming in that have the host app.domain. And the second example is actually what you would see in a microservice or could see in a microservice environment. You have your host, which is the domain, and then you have also a path, like /db/foo/whatever. And then this router would be effective for this. Additionally, in this case, there's also an auth user middleware attached that could, for example, be in basic authentication. So you can manage all of that at this level. And from there, the calls go to the actual service, which is the API, or to the dashboard. The cool thing is you can actually chain those middlewares. So if you have crazy examples and you might need to do lots of your things, you can just chain them in a logical group, and then they get called one after another, and then you have your final result. And those services are basically the abstraction we have for the actual Docker containers. So different load balancer mechanisms are implemented on that level, which also means, for example, if you need to do canary releases or mirroring or more of the advanced scenarios, you would also just configure them once and then can link it to the different services and reuse all your behavior. So in fully, the architecture is, you have the request, it goes to an entry point, from there it goes to a router. For the request, there will be checked if there's actually rules matching. If yes, our middleware is attached to that router. All right, go to the service, go to the container. You're good. As you can guess, what is the cool or the actual groundbreaker about Traffic when we released it 4 years ago is there's a differentiation between the static or startup configuration, which is basically everything Traffic needs to know when the actual process starts, and everything which is completely dynamic, which it just fetches from Kubernetes, Swarm, Mesos, whatever, which is the cool part preventing from having to write a shitload of documentation again. Documentation, it's not helping, but configuration. So what we then figured quite soon is that it's cool to have that dynamic reverse proxy, but it's not like helping fully, because you still have to take care of for example, Let's Encrypt, because you might want to have your services TLS secured. So that is also something it could do. So you have all your certificate management at one level, and you just go from there. And your services don't actually need to bother, because Traffic will do it for you. And as I said, Kubernetes somehow managed to win the orchestrator war. So Traffic, of course, also works with Kubernetes as an ingress controller. Do you all know what is an ingress? What is a pod? Or do I need to? You know? OK. So that's a bit sad to read. And I can't even zoom in. OK, just assume that's a default ingress and Traffic can work with it, because that's just a little light to lead. That's not even better. Maybe I just showed to you in code. Huh?
Select all.
Maybe. Yeah, that's better. What happened with ingresses, and if you follow the Kubernetes community, you will have seen that. What occurred over an ingress, and here I can actually say it then. There is this little block called annotations. It's basically metadata attaching to an object. And that thing just went crazy, because depending on what solution you use, you can put 50 ingresses or so on 50 annotations on your ingress. And you don't actually know what the fuck it's actually doing. So as this is a little bad, we kind of decided to put in a CRD, a custom resource definition for Traffic v2 as an alternative. So you can actually configure by, let's say, semantic behavior, like what should it batch for, to which server does it go, and stuff like that. And you don't have to guess which annotation to take. The CRD will solve that pain for you. As of with Traffic v2, we're not just handling on TCP, but also not just HTTP, but also TCP and UDP. And that's, of course, all implemented in CRD objects as well. So that's kind of cool. I would have time for a quick demo if you want to see it. Otherwise, yes, please. OK. That was fast. All right. And then quickly where I am. Now I need another. OK, I will kill the slides, because slides are boring anyways. I'm currently running just a 3 nodes worker Kubernetes cluster on docs. That should be readable in the back. Or do I need? It's good. OK. So it's just a 2 nodes worker Kubernetes cluster, nothing really fancy. At first, what I quickly want to show is how you actually install that thing, because that's not that complicated. Just opening my code. So it's actually just that. So it's the normal service, as you all know. You need to expose your parts. You give it the type load balancer, so that there is an upfront load balancer going to your service. There is a PVC to store Let's Encrypt certificates because like Let's Encrypt limits are a little hard and you don't want to hit them over and over again. And then comes the actual deployment. Yeah, all of that is like Kubernetes brainfuck, so just ignore. The fun part comes here. You just define your image, you tell it which ports you want it to use, and then you give it a bit of the static configuration. Static configuration can either be applied by command line arguments or by loading a TOML or a YAML file, depending on your scenario. And the only thing I'm giving in here is, okay, your HTTP port is 80, your HTTPS port is 443. I have a separate port opened on 800. I want to activate what we call provider to look up dynamic configuration from our CRD object. And I also tell him, okay, if you go and automatically manage certificates for me, please do it with the TLS challenge. Assign this email address to it. And by the way, the path or the file to store the certificates in are called acme.json. And that's literally it already. So if I now go kubectl apply, we do it. I change in the folder because otherwise I will be typing way too much. There we go. Nope, that's wrong. There we go. Now I'm the right one. All right. So kubectl apply. Just to prepare, the prepare basically, as we can see, it just raises our custom resource definitions and does a bit of namespacing and stuff. So that's what you got to do. And then I quickly just apply traffic. That will now take a minute because on DigitalOcean there will be a load balancer being spawned. In the meantime, as there is a second YAML, which is called dashboard YAML, traffic in itself comes with a dashboard, and you can basically do some sort of inception, let's say. So traffic proxies its own dashboard, so you don't have to like follow with ports and stuff. So what we do for this is we use our CRD, which is the ingress route, and then as we've seen in the semantic example, we give it what to match on. In my case, it's traffic.manuelzapf.io. And please go to this service, and that's essentially it. So quickly going into the control panel, let's see if the load balancer is actually up. No, it's being created, but it's soon to be done. So while we wait the minute, is there a question already?
Any questions?
Oh, now you gotta run. DigitalOcean was faster.
So traffic handles the HTTPS inbound connection and certificate using Let's Encrypt. What about the communication to the backend services?
That is by default HTTP, but you could, with further configuration, set up MTLS between the proxy and your actual backend. If that was the question, I guess, yeah. All right, so it looks like the load balancer is finally up. At least I hope so. Maybe not. Ah, here we are. So, and then I quickly, so we can see something, set the proper DNS, because jib, jib, and jib. So with a bit of luck, and if the DNS god is with me, we will see the dashboard, and there we go. So that's by the default dashboard traffic offers you. As we can see, it's separated between HTTP and TCP, depending on what you have. There is the separation between routers, services, and middlewares. So if we just go for explore the routers, we can see that there is our inception thing basically, which where it's listening on traffic.manuelzapf.io. It's attached to a certain entry point and stuff like that. So that's good. It has a service, and this service is success. It's green. It's passing some host headers, and it's currently used by that routers, and it's like the service backend. It's the internal IP address of that specific container. So far, so good. To actually deploy an application.
Are you showing health checks there? Does it connect directly to the upstream service for the health checks?
Yes, yes. We are relying on the actual. You can configure on your own, but we usually rely on the orchestrator doing the health check job because we don't think we should be the guys doing it. Just a quick example for that. I'm going to just deploy another web application, just that we have something more to see. There we go. It's just a normal namespace. It's an actual deployment, as you all know, so nothing too fancy. There's a service for it. And then there is our own CRD object, the ingress route, which does the job. So that should be deployed. And as I already changed the DNS, if we are super lucky, here we go. So that's fine. The web app is answering. That's just the debug web app we have. So it's basically just printing out all the headers we have. But as we've seen, I didn't need to reconfigure like config file or whatever. Traffic just picked it up. If I refresh here, we will now have 4 routers, 4 services, because everything is like dynamically configured. So that's cool. And the last thing, because then I guess I'm out of time. If I also want to enable TLS by Let's Encrypt and want to have a redirect, things look like this. I define a middleware because I want to redirect. This middleware should be what we call the redirect scheme middleware, which redirects to HTTPS. Then we have our ingress route as one incoming request, let's say, which is matched to the web entry point, which is port 80, and it's listening on host webapp.blah. And also this router has a middleware attached, which is called redirect HTTP. So it's this thing. And then we have a second ingress route, which is only listening for web secure, so HTTPS traffic, and therefore there is no middleware attached. But in this case, I want to have that ingress route TLS secured, and I want to have this done by the cert resolver I call default. So if I just apply that, he will do some stuff. And if we then quickly check for logs, kubectl logs, traffic, there's a shitlot, but that's fine, because it's on debug. But as we can see here, he already starts to like talking to Let's Encrypt using the TLS APN solver. So all of that is done completely on the fly. So with a bit of luck, if I refresh here, and okay, it's not done yet. Sometimes Let's Encrypt is a little slow as well. But then in about 30 seconds, we will have a green certificate and things are fine. Re-getting the logs. One more. Here. Yeah, that was probably my request though. So. Reloading. Then Let's Encrypt is just slow. Then for now, you have to believe me that this usually works. So yeah, that's all. One last thing, I have stickers if someone is interested in stickers. And also, if you're looking for a job, we are hiring massively, so go for the riddle. That's it.
Brilliant, thank you, Manuel. Okay, yeah, let's encrypt the second one. Okay, so we're about done for tonight. It's been told, drinks are being cleared away